Thank you for joining me in this video where I'm going to discuss the Chapter 8 practice test. So in this, I will discuss all the answers so you can make sure that you're feeling comfortable before you take your test. So in our first section, the first section is all about naming polynomials and putting them in standard form. So remember, standard form means putting them in order. So what that means is I need the thing with the highest exponent first, which is going to be that negative 2x squared, then the 3x, then the 4. Okay, so again, standard form just means putting them in order. Naming. So naming based on degree means looking at the highest power. So here the highest degree is 2, okay? Remember, we name a degree 2 polynomial a quadratic. Naming by number of terms, well here I see 1, 2, 3 terms. Remember, the prefix for 3 is tri. So this is going to be a trinomial. All of the name ones for number of terms end in that nomial. Okay, you just have to pick the right prefix. Number 2, same thing. Standard form simply wants me to put it in order. So I'm going to start with a 6x cubed followed by the 7. Its degree, well, a degree 3 we call a cubic function. And number of terms, remember that's going to be your nomial one. This one has 2, so 2 is a binomial. And number 3, once again, same thing. Standard form is talking about putting it in order. So I need the 2x first, followed by 4. Naming it based on degree, well, this has degree 1. Okay, degree 1 things are called linear. The naming by number of terms, remember that's your nomial one. This one, once again, has 2 terms, or has two terms. So that's going to be a binomial. So the biggest thing here is the vocab, okay? Know the standard form means putting the things in order based on degree. Naming it based on degree is either linear, quadratic, or cubic. Naming it by number of terms is nomial, and you have to pick the proper prefix. We're looking to our next section. So our next section is about simplifying by adding or subtracting, okay? So here in this section, simplifying by adding or subtracting, so sum or difference. The key thing to know here is you're going to add or subtract the coefficients. So basically, combine like terms. And that means do not change the exponents. So in this stage of the game, we're not changing the exponents, okay? All we're doing is combining like terms, adding and subtracting the coefficients. So here I see a 7x cubed and a 3x cubed. Now, the one thing that I should actually do before jumping right in is, what do you notice? Well, I notice that this is a subtraction problem. Now, hopefully you guys remember what I emphasized for subtraction. For subtraction problems, my recommendation is the first thing, just keep right as is, but then I recommend rewriting it into an addition problem. Distribute that negative throughout. Change the sign of everything in that second parenthesis, okay? Because when you go to combine like terms, it's less likely you're going to make a mistake while doing so. So after distributing that negative, now I'm going to dive in to combining the like terms. 7x cubed minus 3x cubed. Well, remember, I just subtract the coefficients, and in this point, the exponent doesn't change. Negative 1x squared minus 4 more x squared. It's going to be a negative 5x squared. And then 4 plus 2 gives me 6. All right, and number 5. So number 5, I just have two things that I'm subtracting. So again, I notice 2 minus 11 gives me negative 9. Then again, at this stage of the game, the exponents don't change. So you carry on with the same exponent that is shown in the original problem. And then number 6, the adding one. Well, that one, you just jump right in and you're combining like terms, okay? That one you don't have to worry about having to flip signs or anything like that. So I'm just going to dive right in. 6g plus 2g is going to be 8g squared. Sorry, I should have been saying g squared. And then negative 1g plus 7g is 6g. So again, just combining like terms, you're not having to flip any signs or change exponents or anything like that. Number 7. So as you're studying, pay careful attention to number 7, okay? Because word problems always seem to be kind of the bane of our existence, but if you just pick it apart, it's actually not that bad. So the perimeter of a hexagon, or a six-sided object, is 30t plus 6. 5 sides have the following lengths: 6t, 2t, 4t minus 5, 5t plus 1, and 10t minus 1. What is the length of the fifth side? So I'm going to start by just drawing myself a picture, okay? So there is a six-sided object. Now I'm going to go and label all the sides that I know. Okay, then it's this last side that I don't know. But what I do know is that the perimeter is 30t plus 6. Okay, so what can I do? Well, let's figure out how much I have so far, what I know so far. So I'm going to add up all of these sides that I already know. First thing, so I'm going to add up all of the t's. 6t plus 2t plus 4t plus 5t plus 10t is going to be 27t. Then the constants, negative 5 plus 1 minus 1 is going to give me that. So I determined what I have so far. And now I have to think to myself, well, I know what I have so far, and I know the total length. So that piece that I'm looking for must be the difference between those two things. So I'm going to find the difference between the total and what I have already. And that difference is going to give me the answer that I'm looking for. Now, here I notice a subtraction problem. I remember like what we did up here in number 4. When you're subtracting, the best thing you can do, rewrite it by distributing that negative, because that's going to make it much more difficult to confuse your signs, because now you have it written exactly as you need to. So 30t minus 27t is 3t, 6 plus 5 is 11. All right, moving right along. So, in the next set, simplify each product, okay? So when simplifying products, talking about multiplication, okay? So the note here is we're going to multiply coefficients. And now here, when we're multiplying, this does change exponents. In this stage of the game, now we're going to add exponents, okay? So when you're multiplying, finding products, again, multiply the normal numbers of the coefficients and you're going to add exponents now, okay? So I'm going to distribute this 2x in, okay? So all of these are going to be distributing problems, okay? So 2x times x, well, there's nothing multiplying the 2, but then x times x, both have exponents of 1, so the exponents add to 2. Then 2x plus 7, 2 times 7 is 14, and that time there's nothing changing our x. In number 9, this is another distributing problem. So negative z cubed times z, well, that negative is going to carry through. And now add the exponents. 3 plus 1 is going to give me a z to the 4. Negative z cubed times negative 7. Well, here negative times a negative gives me a positive 7. Then there's nothing to change the exponent on my z. Then one more time, let's distribute this through. 4x times 2x squared. Multiply the normal numbers, add the exponents. 4x times negative 7x, again, multiply the normal numbers, add the exponents. 4x times 5, multiply the numbers, and then there's nothing to change my x there. So again here, the biggest thing, remember, multiply coefficients, add your exponents. And all of those are the distributive method, okay? Our next section, so these same rules right up here still apply down here because we're still multiplying. But this time, we're going to be talking about foiling. Remember, when you multiply binomials, that is a foiling process. All right, so remember foiling. First, so x squared times x squared, or sorry, x times x is x squared. Outside, inside, and last. Being careful that two negatives actually multiply to be a positive. And then, of course, very last step, you combine those like terms and get your final answer to look like that. This next one, same thing, FOIL process. 2x times x is 2x squared. 2x times 5 is 10x. 4 times x is 4x. 4 times 5 is 20. And then, of course, we want to combine our like terms. So we combine those two middle terms to give us 14x and write our final answer just like that. And then the last one, 3x times 2x is going to be 6, and then x squared. 3x times negative 7 is a negative 21x. 1 times 2x is a positive 2x. 1 times negative 7 is minus 7. Then, of course, last step, we want to combine those like terms and get that as our final answer. All right, so that takes care of our front page. So let's take a look at our next one. So the next one, our next one is actually really similar to the foiling process. But remember, when we have a trinomial like that, the foiling process a little bit falls apart, okay? So instead of foiling, what we need to do is take this 3x and send it everywhere into that other parenthesis, okay? So I'm going to make every connection possible. So 3x times 2x squared, multiply the normal numbers, add the exponents. 3x times negative x, multiply the normal numbers, add the exponents, and 1 times 4 is just multiplying two normal numbers. Then we're going to do the same thing with the 1. We're going to send the 1 everywhere into the other parenthesis. So 1 times 2x squared is simply 2x squared. 1 times negative x is simply negative x. 1 times 4 is, oh, I'm sorry, I actually made a mistake in this term right here. I'm sorry, that should be 3 times 4x, so that should be actually a 12x squared. Oh, I apologize for that. And hopefully you guys even noticed in the video, and were kind of thinking that I had done something a little bit strange, multiplying the wrong things together. Okay, so once we get to this stage of the game, now we start combining our like terms. Well, we have the 6x cubed, and there's no other x cubed terms, so I'm just going to leave that one. Have my x squared terms, 3x squared, or negative 3x squared plus 2x squared. So negative 3 plus 2 is still a negative 1, so we'll have negative 1x squared. 12x minus 1x is 11x. And then the lonely 4 at the end. All right, so in the next section, is still foiling, okay? You just have to remember that it's foiling. And the way that you remember is writing it out twice. X plus 4 squared is literally just x plus 4 times x plus 4. When you write it out like that, now you can see the foiling process unfolding. Okay, and then combine your like terms. And I'm going to write it over here. Okay, so this one, it is absolutely critical that you expand it out. Okay, so the method you're going to hopefully choose is expand out those foiling problems. Same thing for number 16. I'm going to write it out twice. Because now I can see the foiling unfold. 2x times 2x is a 4x squared plus 10x plus 10x plus 25. And then, of course, you want to combine those inner like terms. All right, same thing here. So 3x minus 6, 3x minus 6. And of course, once you expand it out, now you can see how this foils. 3x times 3x is 9x squared minus 18x minus 18x plus 36. And combine your like terms. 9x squared minus 36x plus 36 to get your final answer. Now these next couple are a little bit different, okay? These are already written out in a way that you can see that you're meant to FOIL, but something neat happens when they differ by that sign. So watch this. V times V is V squared minus 5V plus 5V minus 25. Negative 5V plus 5V. So the cool thing is with those opposite signs, those insides cancel out completely and just leave you with V squared minus 25. Because that's a really, really cool thing that happens when they're the same, but only differ by that sign. The insides cancel, okay? Let me show you the same thing happens with this next one. 2p times 2p. So remember, multiply the normal numbers and add your exponents. Then here we get minus 20 p squared q, because remember different variables, just kind of mesh like that, then plus 20p squared q. And now one of the biggest things that kids forget in this final connection, 10 times negative 10 is negative 100, but don't forget q times q is q squared. Don't forget that power on that second variable at the very end. Okay, that's one of the biggest things that I find kids forget is when you multiply a variable times itself, you're adding those exponents together. So you get a q squared there. Those inside pieces cancel, again, because of their opposite signs, and you are left with this. All right, so on a related note, number 20. So 20 uses foiling as well, but this one, remember, you have to kind of set up yourself. So find the area of the shaded region. Now here I see areas of 2 squares, okay? You know how to find the areas of those 2 squares. The area of the big square, length times width, and area of the little square, length times width, okay? So you know how to do this. You know how to set this up. And now both of those are just foiling problems. X times x, x times 5, x times 5, and 5 times 5. Then, of course, combine your like terms. And our other one, FOIL again. X times x minus 2x minus 2x. A negative times a negative, don't forget that becomes positive. And of course, combine your like terms. All right, so I have the area of my big square and the area of my little square. And the thing that I need to look for now is how do I find just the area of the shaded region? Well, it's not including the small square, okay? So it's basically I want the area of the whole big square, take away that little square, okay? So remember that means I'm going to subtract. Okay, if I subtract those two, that leaves me just that little shaded region, okay? When you're subtracting, remember the biggest thing you can do to help yourself, take that negative and distribute it throughout, okay? So your first one doesn't change, but you do want to change it into an addition problem by distributing that negative, okay? So x squared minus x squared just cancels out. 10x plus 4x is 14x, then 25 minus 4 is 21. So again, the process behind this, find the area of both squares and then simply subtract the areas. So that takes care of all of the multiplying stuff, okay? Multiplying always comes down to distributing or foiling. Those are the two big things that we focused on. Okay, so after all of that, then we dove into the second half of the chapter. The second half of the chapter was all factoring, okay? So when we're factoring, remember, the biggest key is pulling out the greatest common factor, okay? So I always begin every single problem by looking to see, is there something that divides out? Biggest strategy, you always start there. So for example, number 21, I look at 12x and 15, and I see that a 3 divides out of both of those, okay? So remember then, picture dividing a 3 out of both of those. So 12x divided by 3 leaves me 4x. 15 divided by 3 leaves me a negative 5. And that one, that's as far as I can take it, okay? Remember, only quadratics and stuff like that can break down even further. So something linear like this, I'm already done. There's nothing more to be had with this one. All right, number 22. So, number 22, again, look to see, is there anything that I can pull out of this? Well, 14, 28, and 21 are all divisible by 7. N cubed, n squared, and n, because there's an n everywhere, I can pull out the smallest exponent of n that I see. Okay? And now I need to see what I have left. But again, now, picture dividing out a 7n. So 14 divided by 7 is 2. N cubed divided by n to the first. I subtract my exponents. That leaves me with an n squared. Divide out a 7n. So 28 divided by 7 leaves me with 4. N squared divided by n, 2 minus 1, leaves me with n. And here, 21 divided by 7 leaves me with 3. N divided by n cancels out and just leaves me with that. And so for this one, now, I'm going to give you just a quick little explanation. So here, you are hopefully looking at this and saying, hey, I could potentially keep factoring, and you are exactly right, okay? But sometimes you're going to come across something that actually does not continue factoring, okay? So I would always like you to check to see, hey, does what I have left, does that factor? If not, then this becomes your final answer, okay? Don't try to force it to break down in a way that doesn't work. If you can't break it down further, simply leave it. And number 23. So number 23, I see 15 and 20, both of which are divisible by 5. I see b squared and b in both terms, so I can pull out the smaller of those exponents. I see c to the 4 and c to the 5. Again, I can pull out the smaller of the exponents, okay? So that is going to be what I can pull out. Now again, picture dividing that out of both terms. So 15 divided by 5 is 3. B squared divided by b is just b. C to the 4 divided by c to the 4, well, that's just gone then. Then, of course, again, pulling that out of the other term. 20 divided by 5 gives me 4. B divided by b is gone. C to the 5 divided by c to the 4. 5 minus 4 leaving me with just c to the first. So remember, here you can pull out the smallest exponent of each variable that you see. Now, this next piece is where our two parenthesis factoring comes in, okay? So starting from here, this is where I'd like you to think, all right, quadratic trinomial, how can I get my two factors? So remember here, to get r squared, we need r and r. To get 9, we either need 1 and 9 or 3 and 3, but they have to add to 10. So obviously I need 1 and 9. So again, this is when you're dealing with quadratic trinomials, okay? This is how you do it. So let's move on to the next one. Again, quadratic trinomial. Let's set up my parentheses. To get g squared, I get g and g. To get 24, well, remember that one has some options. And I always want to think to myself, well, because that 24 is actually negative, that's telling me that I need two numbers of opposite sign. Okay, remember all of that sign analysis that I had us doing? And then when I add the two numbers together, with one of them being negative, I want to get a negative 5. Okay, so I can do that by using 3 and 8. They multiply to negative 24. When I add them, they give me negative 5. So remember, your signs here are also very, very important. 26, quadratic trinomial. So m times m will give me that m squared. Oh, to get negative 48. So that has quite a list of numbers. So 1 and 48, 2 and 24, 3 and, let me check, just make sure I put the right thing up on the board. 48 divided by 3 gives me 16. 4 and 12, 5 doesn't work, 6 and 8. So here I have quite a few options of things that multiply to 48. But again, notice it's a negative 48, so I know I'm looking for two things of opposite sign, okay? Always have that sign analysis. Decide what types of numbers you're looking for. And then I want a positive 2, and the one that fits is 6 and 8. But I need the 8 to be positive and the 6 to be negative to give me that positive 2m in the middle. All right, so that's our basic two parenthesis factoring. Now, of course, it can get a little bit trickier than that. So let's continue on to our back page. So now here, number 27, I still have a quadratic trinomial. Nothing pulls out of it, okay? So I have to set this up to get a 2d squared. Well, to get a 2d squared means, or sorry, 3d squared, means I need 3d and d. That's the only way that I can get 3d squared. And I need to multiply to 5. Okay, well, lucky for us, there's only one combination that works. Now, I want you to focus on the fact that this is positive, so it means I'm looking for two things of the same sign, and this is negative. So what that's communicating to me is I'm looking for two negative values, okay? So remember, sign analysis is everything. And now when I fit these together, okay, when I fit them together, remember what you're looking for now is these combinations to give you that middle term. So here, negative d minus 15d, that does give me the negative 16d that I'm looking for. So remember, it's about those connections giving you what you want. All right, so 28. So this one I noticed there actually is something that pulls out of both of those, or all three of those. So I notice all of them are divisible by 2. And the other thing I notice is a y cubed, y squared, and y. So all of them have a y in them. So I can pull that out as well. So again, now picture dividing a 2y out of each of those. So 2y cubed divided by 2y. Well, here, those 2's cancel, and y cubed divided by y is y squared. Divide out 2y. 16 divided by 2 is 8. Y squared divided by y is just y. And then, of course, 30y divided by 2y gives me 15, and then the y's cancel out. Now, here's where I said that whenever you pull something out, still look to see if what you have left behind can factor. okay? Because this time I actually can take this further, okay? I can break down that y squared plus 8y plus 15, because to get y squared, I can use y and y. Two things that multiply to 15 and add to 8. 3 and 5 multiply to 15 while adding to 8. So remember, if you can, keep going, okay? It's not always possible, but when it is, you should be doing so. 29. So 29 is a special one, okay? Remember, is a type of factoring that I said is actually the easiest type of factoring, but that also makes it the easiest to forget. Okay, so I have a binomial. It is only two terms. You were subtracting, and both of the terms are perfect squares. X squared comes from x times x. 64 comes from 8 times 8. So remember, I always start with the opposite signs, okay, the plus and the minus, because that's how I eliminate the middle terms. Then x times x gives me the 64, or sorry, gives me the x squared. 8 times negative 8 gives me the negative 64. And because of the minus, that's how those interconnections cancel off. Okay? So remember the difference of squares pattern, because again, it's the easiest pattern out there, but that also makes it the easiest to forget. Okay? Same thing with this next one. Okay, this is another difference of squares. To get 9x squared is 3x and 3x. 4 is 2 and 2. So when I recognize a difference of squares, I always start with my plus and minus, and then I just fill in those pieces that I already broke down. 3x and 3x, 2 and 2. So again, the easiest one out there, but you have to be careful just because that also makes it easy to forget. So, number 31. Now the thing about number 31 is it's not written in order. Notice my powers are out of order. So that's going to be my first order of business here, is I'm going to write it so it is in order, okay? Factoring has to be in standard form, otherwise it's going to be much more difficult to see what's going on. So when I write them in order, now I see some things I can pull out, okay? I want to pull out a negative 3. Each of those are divisible by 3, and because the first term is negative, I'm going to pull the negative out with it, okay? Because I've never taught you how to factor with a negative inside there. Then I see an h to the 4, h to the 3, and h squared. You can pull out the smallest exponent that you see. And when you do that, now let's see what we have left. Well, negative 3h to the 4 divided by negative 3h squared just leaves me a 3h squared. Negative 18h cubed divided by negative 3h squared. Divide the normal numbers, subtract the exponents. 3h squared divided by negative 3h squared. Divide the normal numbers, subtract the exponents. And there you have it. So this is another one of the situations. You should check to see if that factors more. However, when you check it, what you're going to notice is that doesn't continue breaking down at all. So again, don't force it. If it doesn't factor, don't try to force it to continue to. That is actually the end of the line for this problem. All right, let me erase this so I can scoot it down even more. So 32. So once again, I'm seeing some things that can pull out. I see each of those is divisible by 2, and there is an x in everything. When I pull that out, 2x cubed divided by 2x leaves me an x squared. Negative 2x squared divided by 2x leaves me a negative x. Negative 24x divided by 2x leaves me negative 12, okay? So remember, pull out a GCF first if at all possible. Now, here's a case where it actually does continue factoring. Okay, I actually can get my two parentheses out of this. X squared comes from x and x. Two things that multiply to negative 12. So that can be 1 and 12, 2 and 6, 3 and 4. I do notice that it's a negative though. So that means I'm looking for two things of opposite sign. And to end up with a negative 1x, I'm going to need a minus 4 and a positive 3. Because those multiply to negative 12 while adding to negative 1. And number 33. So the end of the line for our factoring. So number 33, nothing pulls out. So I just have to look to see how can I get a 3x squared. The only way to get 3x squared is 3x and x. And the nice thing is to get a 5, you have to use 1 and 5, okay? Now the thing I'm noticing though is that it's negative. So really one of those gets to be negative, okay? So it's either negative 1 and 5 or 1 and negative 5 that I'm looking for, okay? So let's take a look. So here, if I think it's 1 and 5, I'm going to have 1x and 15x. So knowing that I can make one of those negative, is it possible for me to get a 14x? And the answer is yes, it is. Knowing one of those is negative means I can plot that negative right there, and that gives me the 14x. So what that's telling me is this needs the negative, and that needs the positive. And the really neat thing about all of this is if you're ever questioning if you've done it right or anything like that, you can always, always FOIL it out to get you your answer. So that's it for the bulk of the material, okay? Now, I do want to take a moment to go over the bonus questions for you in case you'd like the review to take a shot at our bonus questions. So the first one says, what is the surface area of a cylinder with radius x plus 2 and height x plus 10? The formula for surface area of a cylinder is as follows. So here, I can just start plugging things in. So 2 pi, and then the radius it gave me is x plus 2 squared. And then the radius again, and the height. Okay, so for this one, the first thing I can do is just start plugging those things into the formula. Okay, and now, of course, this right here, that squared, is going to have me write this out twice. Okay, you expand out that squared, because now you can see that this is actually a bunch of foiling. When I FOIL x plus 2 times x plus 2, I'm going to get this. So I'm bypassing some of the work just because I don't want you to have to sit here and watch me do things that you already know. So here all I've done is FOILed that to get this, FOILed that to get that, okay? I'm just bypassing showing the little piddly work here so we can get to the big ideas. So once I FOIL those out, now what I'm looking for is distributing in these 2 pi's, okay? So that's going to give me 2 pi x squared plus 8 pi x plus 8 pi. Distribute in that 2 pi. So 2 pi x squared plus 24 pi x plus, that gives me 40 pi. And now all I need to do is combine my like terms. Here are two like terms. Oh, there, I almost wrote the wrong answer. 2 pi x squared plus 2 pi x squared will be 4 pi x squared. 8 pi x, 24 pi x, that's going to add to 32 pi x. 8 pi plus 40 pi is going to be 48 pi. So again, that one is just applying all of the multiplication skills and then the adding skills to combine your like terms. Okay, that's what that bonus question is really testing. And number 35. Number 35, an artist is making a square stained glass window in which a green glass circle is surrounded by blue glass. The sound length of the window is shown and the area of the green piece is 50 pi x squared. What is the area of the blue? All right, so we want to know this area right here. This is what they're referencing. Even though you can't see the color, that is what they mean by the blue. And to find the area of that whole square is going to be 20x times 20x. Oh, 20x, which is going to give us 400x squared. Then we want to take away that green circle. And the cool thing is we don't have a calculation for that. They actually just gave us that is 50 pi x squared. Okay, so we want the difference of those two things. We want to take away the green piece to find just the blue piece. Now they say write your answer in factored form. So factored form means we need to pull out whatever we can. Well, 50 divides both 400 and 50. And x squared can pull out because x squared is just in both terms. So when I pull out the x squared, it gets pulled out. 400 divided by 50 is 8. Here I pull out the 50 and I pull out the x squared. So all I'm left with is the pi. All right, so there is your whole test. Thank you for watching through this. I really hope it benefits you as you're studying for your test. If you still have any questions, please make sure to come in before or after school to ask for help, or just email your teacher and we will get back to you as soon as we can to clarify any misconceptions you still have.